Once again, warm-up number 52. By now you should be able to do all four of them. Let's do about, what, 6 minutes? 6 minutes? Once you're done with the warm-up, make sure you make your way to get a graph paper. Today we're moving on to a new parameter, so grab at least 2 for today. All right, while you're finishing up really quick, share with your neighbor what you got for number 1 and number 2 so I can call on someone to help us out. Number 1 and 2. Share with your neighbor what you got. Number 1 and number 2. Number 1 and 2. Once again, if you have any questions, you know to ask Jaden. He's got it. What's that? Oh, give me a second. There's the code again if you haven't logged in. 3U6HQ. 3U6HQ. All right, number 1, to complete the square. Let's see what you do to complete the square, or can somebody complete the square for me? Get me started, please. JP. Close. Said x squared plus 10x plus 16. It's close. Diego, Romo, plus what? 10 over 2 squared. Hands if you got that. All right, some of us. So this becomes x squared plus 10x plus 25. So that's the first part. Second part, factor. Pass someone, Diego. Anaya, factors. X plus 5. Squared. Hands if you got that. Some of us. All right. Number 2A. 2A. Fabian, what did you get? Square root of 9. 3I. Yes, 3I. Hands if you got 3I. Yes. All right. Some of us. 2B. Fabian, pass someone. Lorena. 2 square root of 3 over 3. That is correct. Let's go. We got this. And C. Pass someone. Julian, what'd you get? You didn't finish that one? Okay, let me help you. 9 times 5, so that becomes 3 square root of 5. Hands if you got that. Looks about right. All right. Number 3, factors for number 3. Jaden, what'd you get? Which becomes what? Thank you. Hands if you got that. And the last one, can you walk us through the process for this one, please? Let's see. How about Diego? Go. Uh-huh. Subtract 7. Negative 2x, yes. Negative 2, both sides. Y minus 7 over negative 2 equals x. X minus 7 over negative 2 equals y. Can we leave it in y form, guys? No, we're in function notation, so what do I write? Okay, x minus 7 minus 2 equals f inverse of x. Ooh-wee, let's go. Hands if you got that by yourself. Okay, some of us. All right. Copy the agenda for today. Warm-up number 52, we finished. We're still with transformation of functions, and today your homework plays 3 transformations only. So as we're approaching the different parameters, today we're going to add one more. That's why I asked you to get a couple of those graph papers, because we're going to need them. And, you know, and I know your notebook has the graphing capability, but it doesn't allow for a lot of values, because it only goes up to, I think, 30. And if we do 15 and 15, it runs out of space. So make sure you grab yourself some graphing. All right? Once again, warm-up number 52, we're done. We're still with transforming functions, and we're working with 3 transformations for today. So there is no asynchronous code for tonight. Last night's home play is there. Make sure you turn that in on Canvas before you leave today. And tonight's home plate is on the screen. Take a picture of that really quick. Yeah, it's over here. And once again, if you're still struggling with some of the graphing and transformations, tutoring today, it's free. Let's go. Who doesn't like free stuff, right? All right. So today we don't need a Cornell note. We're going to do the notes on your graph paper. So if you have your graph paper, turn to the side where you have the 2 medium-sized graphs, the coordinate planes, and I want you to write the objective at the bottom left. I can transform a function using different parameters. I can transform the function using different parameters. That goes on your graph paper at the bottom left. So the 2 medium-sized ones. Canvas? Yeah. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, here's one. They wrote a relation where you could get the same output no matter the input. Okay. Not bad. A relation that contains the same input or output. Okay. A relation where every input has one output. Okay, I like this one. So remember, for every input, an exact output. Okay, not bad. All right, so with that said, where have we been? So we've been to the 2 parameters so far, h and k. H goes side to side, positive goes to the right, negative goes to the left, k goes up and down. Okay? So with that said, look up to the screen. We have f of x equals x cubed. There's our parent function. So now I'm looking at the blue one. Look at the blue transformation. Tell your neighbor where we're going to move the original function to according to this transformation. Tell your neighbor, please, where do we move that to? Noel, what do you think? Right. Hands, have you said right? Yeah, right 6/10, that is correct. Now let's go to the green one. Look at the green one. Where do we move the original to according to this green one? Tell your neighbor, please. Alyssa, what do you think? 2 up. That is correct. Hands, have you got 2 up? Yeah, and so on and so forth. And the bottom one, this one, tell your neighbor where this one's going to move the original to. Where's this one going to move it to? Everyone? 7 to the left, yes. So therefore, all the transformations are here. We already saw that. By now we should know that because today we're moving on to the new parameter, yes? So at the medium-sized graph, you have plenty of space at the top. I want you to write this next problem, please. Example super-duper Q, and it reads, graph f of x equals x squared using the domain -3, -2, -1, 0, 1, 2, 3, and write 3 different tables, one in black, one in green, one in red, and then we'll get started as soon as you copy that. I'll give you some time. Copy and caps on. Here we go. So for the parent function f of x equals x squared, we're going to build our table. So I'm just going to show you the process one more time for just the first value. And my first value is -3. So what is -3 squared, everyone? 9. So therefore this is -2 squared is 4, 1, 0, 1, 4, and 9. Now yesterday we got plenty of practice from -2 to 2 for this parent function, so today I'm just adding one more value. So let's plot those really quick. -3, 9. -2, 4. -1, 1. 0, 0. 1, 1. 2, 4. And 3, 9. Sketch your parabola. Arrows at the end. And what do we label this one? F of x. There it is. Okay. All right. So today we're introducing a new parameter. Here goes the transformation. So before anything, let me just show you the process for the first couple, and then you should see the process there. Write your utensils down, look up to the screen. All right, here we go. Look up to the screen. So here all the x values are the same as here. Okay, we have our parent function, which is here, which is squared. But now this has 3 f of x. The 3 being a coefficient implies that there's what operation going on between these two? Yeah, multiplication. Therefore, I start at -3, go to our original function, -3. What is f of x? 9. But now it says f of x times 3. So what is 9 times 3? 27. Write that in there, please. Yes? Yeah. Bless you. This says f of x. Good question. What is f of x here? 9. Yeah. Let's go to the next value. -2. -2. What is f of x at -2 of the original? 4. So what is 4 times 3? 12. All right. Do me a favor. Tell your neighbor the next value. Tell your neighbor the next value that goes right there, please. Help them out. Next value. So like that we can ask Valente. Tell your neighbor the next value. All right. Next value, Valente. That is correct. So let's see. F of x was for -1 was 1. 1 times 3 is 3. And therefore this is 0. Can you fill in the rest, please? Finish off. All right. Share with your neighbor, see what they got. Make sure they got the same thing as you. All right, so let's see. Jalen. All right, let's plot those now. Before we do, will we be able to plot -327 and 327? Look at the coordinate plane? No. So let's box these. So like that we know that we're not going to graph those, but we keep them in mind. So let's plot the other ones. -212. Do that in green. -212. -1, 3. 0, 0. 1, 3. And 2, 12. And what do we label this one? Yeah, g of x. Okay. Okay. Writing utensils down, look up to the screen really quick. Now, I'm going to take you guys back in time, like a long time ago in a galaxy far away. Back, let's say more than 20 years ago, believe it or not, we didn't have like cell phones. You're like, what? No cell phones. So sometimes for this kind of home play, I used to tell my students to put together like a little wooden plaque like this with nails. I don't know if you've seen that, with a lot of nails. And then from there, I would come with rubber bands to make me graphs. Can you picture that? So it's a wooden little plate, and then they put nails like that, hammer nails, and then with rubber bands, they would make these graphs. So picture the original graph, this one, the original parent function. So you're at home, no cell phone, you're getting your rubber band, you're setting your parent function, and in walks, oh, hold on, and you don't have any of this because you're working on your wooden plate. In walks your cousin, or who has a little person in your life that sometimes wants everything that you have. You have hot Cheetos, they want the hot Cheetos, right? They walk in and they ask you, what are you doing? Well, I grabbed this one and I'm going to do this one. Question, what one word would you say you need to do to this one to get that one, to that little person in your life? Talk it over to your neighbor. What one word would you say do you need to do to this one to get to that one? Because they don't know all the math. So what one word would you say? Talk it over to your neighbor. What one word would you say? All right, one word. Who's got one word for me? What would you say? Isabella. What would you say? What would you say to the little person that you're going to do to this one to get to this one in your little board? Alex, help her out. Multiply, but remember, they're little kids. They don't know how all the math. What would you say would you do to this graph to get this graph on your little board that you're doing without any cell phones? Joel, what do you think? One word. Well, let me ask you guys. Here's my original with my rubber bands. I have it set. What do I need to do to get this one? Tell your neighbor. What do I need to do to get that one? What do you think, Jose? One word. Okay. JP, I think you got it. What do you think?
I think you like get like you can go like rearrange it or like
Okay.
rearrange like attach on like the rubber band or you have like a new set and put it in a similar shape to that.
Okay. So I'm going to give you the word. I don't know if you see that. This is the original. From this one to this one, that one stretched. Did it stretch? Who said stretch? Some of you? Yes? Okay. Just, say them out. So keep that in mind. Look up to the screen. But here, to stretch, I had this number. And what did it do? It stretched it. We're going to do a new transformation to the original one, but now we have this number. What do you predict is going to happen to the original function to get that? Talk over to your neighbor. What do you think is going to happen to the original to get that one? All right, so let's see if you keep that in mind, see if your prediction comes true. So let's fill this in. Here we go. Let's go to the red one. We got -3. I go to -3. What was f of x? 9. So what is 9 times 1/3? Or 1/3 times 9 is 3. Fill that in there, please. Next one, -2. -2. F of x is 4. So what is 4 times 1/3? 4/3. And if we simplify that, that becomes 1 1/3. Okay. Next one, we got 1. 1 times 1/3 is 1/3. 0, and the rest repeat for the sake of time. 1/3, 1 1/3, and 3. All right, let's plot those in red on the same graph. -3, 3. -2, 1 1/3. -1, 1/3. Let me zoom in so you guys can see it. Zero, 0, 1, 1/3, 2, 1 1/3, 3, 3. And label this g of x. All right. You had your prediction. Did it do what you thought it was going to do? Yeah, some of us saw it. Okay. However, let's see. For this one, stretch. For this one, tell your neighbor one word that would describe what just happened to the original. One word. One word. Alessandra, what do you think? It shrank, yes. But a word that we use in math, it compressed. Yes, it shrunk or compressed. Yes? All right, so let's close this idea all together. Let's write a quick sentence at the bottom. You have space, yes? Let's write this out. If I multiply f of x, which means the original function, by, what do we call this number here compared to that one? What is it? Whole number, yes. If we multiply f of x by a whole number, what happens? We stretch, yes. We stretched the function. Semicolon, if I multiply f of x by what now? Fraction or decimal, yes? We compress the function. At the end, I want you to write 10 Q. Tell your neighbor what that means, please. Yes? Everybody got it? What does that mean? Remember the story? No? 10Q? Yeah? Anyway. All right. You have space at the top right. Is that correct? All right. So let's write our new rule now, including the new parameter. Write that down at the top. G of x equals a times f of x minus h plus k. G of x equals a times f of x minus h plus k. I'm going to change the k to blue. And what do I sketch next to it to remind me what it does? Arrows, yes, up and down, plus for up, minus for down. How about H, everyone? Left, right, right, positive, left, negative. All right? And the A, I'm going to change to red, since it's the new one. I'm going to change to red, and it's going to do two things. It does two things. What are the two things? What's the first thing, everyone? Stretch, yes, stretch. And then underneath just write whole number. And what is the second word? Compress, yes. And then just write fraction or decimal. And by the way, who noticed when it stretched, it went like this and like this. Is that correct? So that means it did it in which direction? Vertical. vertical. Vertical stretch, compress. All right? So from 1 to 5, how comfortable are you with new parameter A, 5, 5, 4s, 5, 5, 4s? Okay, not bad. All right, so do me a favor, send me a picture of your notes really quick. I want to see what you did. Example 1Q at the top left of your big graph paper, write it down. It says graph f of x equals x squared using the domain -2, -1, 0, 1, 2. Today we're not going to focus on the table. We're going to focus just on the transformation without a table. Now, by now, with all the practice that we did yesterday with the parent function, you should be able to graph the parent function without a table, right? Yes. So let me send you the screen. Plot your points, graph your parent function really quick so I can see that you got it. Remind your neighbor what points you're going to use for the parent function, please, if they forgot. What points are you going to use for the parent function? All right, good conversations. Nice. Yeah, we got it, right? And once again, it says from -2 to 2. Some of you are going all the way to -3. Remember, -2 to 2 on the parent function. All right. Let me forward my screen really quick. All right, here we go. Free to help me out with the points for the parent function, please. -2, 4. Hold on. -2, 4. -1, 1. 0, 0. 1, 1. 2, 4. Okay. So here's my parent function. F of x. Okay. So let's start with the easy one. Notice that we graphed it without a table. Good. Look up to the screen. We got a transformation here. Let's start with h and k. Tell your neighbor where we're going to move this graph to. Wait. Did I get the wrong one? Hold on. My bad. There it is. Sorry. Try this again. 2, 4. 1, -1, 1. 0, 0. 1, 1. 2, 4. All right. Now tell your neighbor what h and k will do to the original f of x. What's h and k going to do to the original f of x? Really quick. All right. Brisela, help us out. To the right 4, and then up 2. Hands, have you got that? All right. So here goes the part that we need to worry about before we do the last 2 steps, because that's the easy part. We already been doing that, so we got that. But this is the part that we need to focus on right now. This is A. Is that correct? All right. So let's see. Let me go back to the previous one that we just did. Pay attention to this part. Write your utensils down. Look up to the screen. Check this out. When I started with my parent function, look up, please. Check this out. Look at this point and this point. Let me zoom in. I'm looking at the black graph. So these 2 points, what is the y value? 4, okay? Those 2 points became these 2 points. What is the y value of those 2 points? 12, okay? So they were 4, and they became what? 12, okay? Let's look at the green function. It was a 3, right? It went from 4, and now it became what? 12, okay? with that said, here's these two. Oh, wrong one, not that, again. Here's these two. The y value is 4. Tell your neighbor what the y value would be to the new transformation according to that. Talk to your neighbor. What would be the new y value according to that? All right. Bisela, pick someone. Lorena, what would be the new y value? For right now, for these two to the original, 12. Hands have you said 12. So these 2 points from -2, it's going to go all the way to what? 12. So do that in red, please. And I'll show you why in red. Or a different color, that's fine. So -2, 12, and +2, 12. Okay, we got those. Next, the bottom 2 points. These 2 points, the y value is 1. But now according to this transformation, tell your neighbor the new value for those 2 points, the new value for those 2 points, new y value. And Lorena, pass it to someone so they're ready. Oh, Fabian's going to be ready. Okay. So, original was 1 of y. So, Fabian, what would be our new y value for those points? 3. Hands if you got 3. Yes? So, at 1, -1, 3, plot that. 1, 3. And, of course, the vertex doesn't change. 0, 0 stays the same. So, sketch that in red. Now check this out. I did that in red because I only did what transformation? A. Tell your neighbor what's left. What's left in order for us to finish the entire transformation? What's left, everyone? Jose. H and K. So that means we move all the points what? 4 to the right and 2 up. So let's start up here. 1, 2, 3, 4, 1, 2. This one, 1, 2, 3, 4, 1, 2. This one, 1, 2, 3, 4, 1, 2. This one, 1, 2, 3, 4, 1, 2. And this one, 1, 2, 3, 4, 1, 2. This is our final transformation. And since this is our final, what do we label this one? G of x. All right? All right, so far, from 1 to 5, how comfortable are you up to right there with A, H, and K? 5, 4, 5, 4, 5. Okay. All right. So before we move on to the next one, I got this next one. Really quick poll on your screen. All right. So, y'all ready? All right, turn your graph paper to the small graph in the back. You have one medium one open, yes? It's empty? All right. All right, here we go. I want you to label that one label it example Michael Jordan Q, MJQ, MJQ. Let's go. All right, so let's see. Without a table, graph me f of x equals x squared. I'm not even going to give you a domain. 30 seconds. You're doing it on paper right now first. Make sure you label it f of x. All right, show your neighbor what you did. Make sure they have the same thing as you. All right, we need 5 points. Let's see, Jessica, help us out with the 5 points. -2, 4, bless you. Uh-huh. Yes. Yes. Let's go. Let's go. And that is our f of x. Okay. So, we're going to transform that one like this. Write this down. G of x equals, give me a number. 2. Okay, I'll take 2. F of x minus, let's do 7 minus 3. Before we do the 2, tell your neighbor where h and k are going to take the whole thing. Where's h and k going to take the whole thing at the end? H and K. Jaden. Send to the right. And 3 down. Hands, have you got that? All right. However, before you do all that, you need to do this. All right. Do that by yourself. For right now, I'm going to give you the y values of these 2 points. This one is 4, and this one was 1. 4 and 1. And now we have that. All right? Home plate for tonight's on the screen. All right? I'll stop the video right there.